Hey guys, welcome to part C. This is our second homework this week that goes over the other half of Unit 2's learning targets. This page is going over if things are proportional, so quickly check your answers and stick around if you forgot any part of this and need a review. For the second problem, the second table was proportional. For number 3, Team C shows a proportional relationship, and then when you graph Team C and Team D, you get these two graphs, and you should probably know why this one is a proportional graph and why this one is not. If you're not sure, please stick around and watch the video. Alright, so remember what a proportional relationship is. It is a relationship where the numbers are related by the same factor. You can always multiply by the same number, which is called the constant of proportionality, or the unit rate. So if we can find one number to multiply by here to get 10 and by 20 to get 25, that would make this proportional. Similarly, we would look for that number here. So you can look for that number by dividing. Like we could do 10 divided by 8. 8 goes into 10 once, and then I would have to add a 0 and a decimal. 8 goes into 20 twice, and then 8 goes into 45 times. So it looks like 8 times 1.25 equals 10. If we do the exact same process with 25 divided by 20, you will end up also getting 1.25. So that's one way to show that this table has a proportional relationship. But there's another way, which you might find to be easier. The other way, instead of looking for that constant of proportionality, is just to simplify the ratios and see if they're equivalent. So let's start with 8 to 10. If I simplify that, I can divide them both by 2 to get the equivalent ratio of 4 to 5. And then, if I take a look at this one, I see that 20 and 25 both have a common factor of 5, which would also give the same ratio of 4 to 5 and 4 to 5. So those are the two ways you can tell if a table is proportional, whether they have the same constant of proportionality to multiply by, which was times 1.25, or they both simplify to the same ratio, 4 to 5. And if you tried that over here, you would end up getting 3 to 5 and 4 to 5, and those are not equivalent. Also, this would be times 1.25, but up here this would be, oh man, I think it's times 1.6 repeating. And since the constant of proportionalities are different, we would say that this one is not proportional. Alright, so same deal here. We could use division to find the constant of proportionality, or we can just simplify the ratios. I'm going to use the second strategy. And I see that they have a common factor of 3, so that would be 4 to 3. And then for 16 to 10, they have a common factor of 2, and that would give me 8 to 5, and I see that these are not equivalent, so it looks like this is not a proportional relationship in this table. Let's check out this one. So 6 to 14. Well, they're both even numbers, so I can divide them both by 2. That would give us 3 to 7. And then 15 to 35. Those both end in 5, so I know they're divisible by 5, which gives me 3 to 7. So it looks like this table shows a proportional relationship because both ratios simplify. Actually, both ratios are equivalent. 6 to 14 is equal to 15 to 35 because they're both equal to 3 to 7. Alright, so on the back we have Team C and Team D, and we want to know which table shows a proportional relationship. And there's two ways you can tell right away that the answer is Team C. So one, you can just start looking for that constant of proportionality. And so 1 times what equals 3? Well, it's 3. And then 2 times what equals 6? It's also 3. And notice that this is a constant relationship. Even works for the 0, 0. And if we were to write this as an equation, it's like we're taking the hours, we're multiplying it by 3, and it's equaling the distance. So Team C is proportional. Team D is not, and there's two reasons why. First of all, it doesn't start from 0, 0. It needs to start from the origin, because there's literally nothing you can multiply 0 by to get 4. It's impossible. The only thing it could start off with is 0, 0. And then, to further prove it, 1 times 6 would be 6, but then 2 times 4 would be 8, and 3 times something crazy equals 10. So it's looking like this one is not proportional, and Team C is, because it has a constant of proportionality. It's always times 3, and you can write an equation for it. H times 3 equals D. Alright, and for the last part, I'm not sure if you're going to need to do this on the state test, but it's a good thing to review. We need to graph the points in these tables. So I'm going to clear this ink so I can see it. And then here, the first ordered pair is 0, 0. The second ordered pair is 1, 3. So let's go do that. So let's start off with 0 hours and 0 miles. So that's 0, 0. Then the next one was 1 hour and 3 miles. So x always comes first and y always comes second. And this is our x-axis right here. And this is our y-axis right here. So I'm going to go to 1, 3. Should be right there. The next point would be 2, 6. 2 hours, 6 minutes. Or 6 miles. 3 hours and 9 miles. So that's 3 and 9. And since this is proportional, it's going to kind of follow that same pattern. So you should get something like this. And then let's take a look at Team D. So Team D starts at 0 hours and 4 miles. So that means we're going to start at 0 on the x-axis, but then at 4 on the y-axis right there. And then we have 1, 6, so 1 hour and 6 miles. 2, 8, so 2 and 8. And then if you keep looking at that, it's following the same pattern, where it goes up 2 miles every 1 hour, and that would look something like this. Alright, so how is the proportional graph different from the non-proportional graph? Well, if you remember, and I guess I'll write over here, a proportional graph has to have two things that are true. Number one, it has to start at the origin, or 0, 0. And if you look at Team D, it doesn't start. The origin is right here. It's this point. And Team D does not start there, but Team C does. So that's one thing. The other thing a proportional graph needs is it needs to go up or down at a constant rate, which is a complicated way of saying the line should be straight. And notice that here, both of the lines were straight because both of them kept going up by the same amount, but both of these things need to be true. So it has to start at 0, 0, and it needs to go up in a straight line at a constant rate. So that's how the proportional graph differed from the non-proportional graph. Alright guys, come check out part 2, and I hope that this review is helping you. I got bars.